I mean, you're not like huge foods, but they're really good. Sorry.
All right, hey everyone. I just want to give a few announcements before we begin. First, on Piazza, you should have seen a link, which is essentially where all the lecture videos will be posted. So after discussing with Anna, we decided that we're gonna release lecture videos. Just a word of caution, which is we're not SCPD recorded, which means these videos may not be of as high quality as you might expect out of Stanford. So sorry about that, but we're doing the best we can. Yeah, and also currently we're providing both screencasts and video. I just want to quickly ask, like, first, who watched either the video or the screencast? Anyone here did? Okay. Which one do you prefer, the video or the screencast?
Who prefers video of the people that did one? Who prefers Screencast?
Okay.
Who has no opinion in this matter?
Okay, cool. So,
yeah, or
or-
rather, which one did you watch? Which one did you choose to watch?
I just feel like we wouldn't be able to give an opinion unless we've watched both.
That's true. So I
Yeah.
guess, which one did people choose to watch?
Yeah, like if you were given both choices, which one would you choose to watch? So it seems like it's the screencast.
It seems like Screencast.
Okay. All right. Cool. All right. Otherwise, it's 3:30, so let's get started. Today we're gonna talk about streams. Okay. So streams are not the newest or coolest C++ library. In fact, streams are probably one of the oldest libraries. But it's important to start with streams because when you first starting to learn C++, right, your first program is probably a Hello World program where you learn how cout works. And one of your, probably not second, maybe like second or third program, you'll start to begin to want to use user input, right? Like if you went to 106B lecture yesterday, Cynthia did a Hamilton example where part of that program is the user has to first type in an integer, okay? I think Cynthia briefly mentioned about the Stanford Library. In CS106B, they want you to use the Stanford Library to like prompt for user input. And one of the reasons for that is because streams are really messy. Okay? As we'll learn today, there are a lot of just nitty-gritty details of streams. And you can see why if you aren't interested in the low-level details of streams, why you might not want to learn that. Okay, but we're in CS106L. We're gonna dig deep into the streams library, and hopefully by the end of next Tuesday, you'll actually have all the tools to implement most of the user input Stanford libraries. Okay, so on Tuesday we'll fully implement getInteger. All right, we'll implement the entire fully functional getInteger, which is pretty cool. All right, so let's get started about streams. Correct me if I'm wrong. Cynthia covered basic I/O streams on Wednesday, but she did not cover file streams because file streams are on Friday. Is that correct? Okay, awesome. So today we're gonna first give a brief overview of what the stream abstraction is, and then we're gonna talk about the most basic type of stream, which is a string stream. Just as a note, string stream is a bit of a tongue twister. So if I ever pronounce it wrong, like if I say stream or string or something like that, I'm referring to string stream, okay? Then we'll talk about state bits, and our discussion on state bits will transition into a full discussion on input-output streams. And in particular, we're gonna think about what happens when there is an error, when the user types in something that the stream did not expect, okay? Cool, let's get started. So the reason why we want to use streams is because oftentimes we want our programs to be able to interact with external devices, right? When you are programming something, not every piece of information you're going to use is self-contained inside the program. Oftentimes you'll have to be using external resources. The most common ones are the ones you see over here, the console and keyboard. That's the most common one you'll be using in pretty much most CS classes. And another one that you'll use is files. Cynthia will go over files a lot on Friday. there are two other pretty important devices that streams can be used on. One is other programs, where if you look on your laptop, you actually have multiple applications running at the same time. Right? Think about what happens when you copy paste from one application to another. Right? Somehow, your computer is transferring information from one application to another one. Okay, and then the way it does that is through some sort of pipelines. Now, we're not going to go too deep into that because that requires understanding not just the C++ language, but some concepts that you'll learn in 110. One of the coolest things about streams is if you go deeper into streams, you'll learn these things called sockets, which are the basis for how networking happens. Okay, if you take CS 144, you'll learn more about how sockets work. Today we're just going to mostly cover console and keyboard and files because that's the most important ones that you'll be using when you write your programs. So why might we want to use streams? Well, one thing that we might want to do is, for example, we might want to, given a file, we might want to read information from a file into some variable in our program. All right? So for example, if we have a file that has the number 3.14 in it, we sometimes want to be able to read from the file and use it as a double in our program. Now, to go from here to here, you can think there's actually two steps involved, right? The file itself is saved in kind of like a string format. So you actually have to first be able to read that string from the file. Then after reading that string, then you have to be able to convert that into a double. Okay? Another example I like to use, we haven't covered structs yet, we'll cover it next class, but suppose you had like an object which represented a date, right? There's no easy direct conversion between a date object and how do you print it to a console. So one of the first steps you have to be able to do is convert a date into a string. All right? The key portion is the conversion from some variable or some sort of object inside your program. You have to convert that to a string before you can actually write it to a console or to a network or to anything else. Okay? And then in this case, there are two major challenges, as you can see. One is we actually have to be able to read that string form. And then next, we have to be able to convert between the types. What the stream does is it abstracts away this portion of the stream. Okay, so when you are using streams, you don't have to worry as to how the stream itself is actually writing or reading from your external device. Okay, a good example of this, the stream that you've been using so far is called cout. Cout is an output stream. Now, you've been writing stuff into cout, but you've never actually thought about how cout interacts with the console. Right? You never actually had to go into cout, figure out what was being read, figure out what to print on the console. No, you just had to send it to cout, and cout takes care of it. Okay? And then the basic idea is any variable in your program, you're able to either output it into your stream, and it will take care of any sort of read-write it has to do, or you can read from the stream. For all intents and purposes, you can imagine the stream as just an array of characters. It's just a bunch of characters that you can read or write from. Okay, at this point, what are your questions? Okay, let's move on. So let's quickly talk about string streams. So what a string stream is it is a stream that's not connected to any external device. All right, so this is nice because now we can just focus on how this type conversion works. I had one more slide over here. Okay, but before I go to the example, there are two kinds of streams, output streams and input streams. Okay, output streams like cout are streams where you can write to. So for example, in here, you can write output into a stream. Like, remember when you did cout, you wrote cout, the alligator symbol, your variable. Okay. Other kind is called input streams, which is you use the other notation. When you use cin in 106B, you said cin, the alligator, your variable. Okay? All right, now that we have that done, let's talk about string streams. So, by the way, I'm going to use the terminal to code the examples. You don't have to worry too much about what's going on over here. You don't have to use the terminal for this class. I just got some feedback from you that some of you would like to see some coding done on the terminal, so that's what we'll be doing. For your assignments, you'll mostly be using Qt Creator. Okay. Cool. Let's get started. So stream.cpp. All right. So the first kind of stream we're going to talk about is called an O-string stream. An O-string stream stands for an output string stream. Right? So remember, output. Do you read or do you write from it? Right. Right? Yeah. So remember, for output, kind of like cout, you can send information into an output string stream. When we construct an output string stream, we can give it a initial string that it has. So when we write this line, for example, let's go to the slide. What it does is it creates the O-string stream and it initializes it with those characters. So inside the array of characters you think about, initially we start with those characters. Now, one of the most common methods you'll be using for string streams is called str. Anyone want to guess what that method does? Yeah, exactly. It basically takes whatever is in the entire array and it just converts it to a string. Okay, so for example, if we try compiling this, okay, I always mess this up. C++17 wall stream.cpp o string. Okay, cross your fingers, it runs string. Yeah, so you can see when we try printing string stream, it prints Ito and green tea. All right, so that's what it does initially. You can see over here, it prints Ito and green tea. Now, we can also try writing to the string stream, right? That's why it's called an output string stream. We can try writing to it. So for example, over here, we can say OSS, and then we're going to write 16.9. We're going to write space ounce. Okay. Now we can try printing out what's inside the stream. Okay, now think for 10 seconds. Try to think what is going to be printed. All right, let's check if your answer is correct. Compile. It printed 16.9 ounce NT. Okay, so let's try to think about why that happens. Or does anyone want to guess why that happens? Oops, I showed the answer. Yeah, when you initially create a stream, the position that the stream is set to is always at the beginning. So when you try writing stuff to it, it basically overwrites whatever you had before. All right, so if you print it right now, you'll get 16.9 NT. All right. If you wanted to open the stream at some other location, you can go to the Stanford Libraries. You don't have to memorize this, but there are options when you create your stream. There are different options you can give the stream to make it operate differently. For example, one option you could give is you could pass in this argument, 8. 8 stands for at end, which means when it opens the stream, it opens it at the end. Okay, so for example, here, if we open it with 8, what happens is it's going to initially start the position at the end. Okay? Make sense so far? Question, yes?
When you initialize the O-string stream, how much space does it have? So how many characters is it for just the amount that you need? Or like, if you keep on writing to it, does it at the end always go into other memory, or do you keep on adding more space?
Yeah, good question. So the question was, when you initialize the string stream, how much space is allocated initially? Now, exactly how the string stream allocates space, you don't have to worry too much about that. But what happens is you can write as much stuff to it as you want. There is a limit, and there's actually a constant, which represents like how much stuff you can write to it. Okay, but for all intents and purposes, it's like as much stuff as you want to write to it. There's no limit. I think it's like 2 to the 30 something. You can write as much stuff you want to it as you want. Okay. Exactly how much space is initially allocated? I guess what happens is it initially allocates some space, and then it increases the space when you need to. Yeah. Initially, how much, that depends on whoever implemented this library. Right, good question. Any other questions? Okay. So for example, another thing you can do is, let's just write one more. Yeah, so you can do that, but just for example, let's remove that. Oops, I'm in Visual Code. There we go. Let's remove this for our example. We can write something more. We can write OSS, let's say pack of 12. Okay, so if you do that, then we print cout oss.stir. compile. Yeah, it prints as you expect. All right. One thing to notice is, notice here that 16.9, what's the type of 16.9? Yeah, it's a double, right? So what the stream does is it takes whatever type you give it and it automatically converts that type to the string representation of that type. So for example, here, if it's a double, it converts it to a string that has that double. If it's an int, it converts it to the right place. All right, yeah, question, yes?
Why didn't the pack of override the 16.9 if you're writing again to the stream?
Oh, good question. So you're saying, so we wrote 16.9 ounce here. Why didn't?
The
Uh-huh. Good question. So if you look at the slides over here, what happens is when you write stuff into the stream, it actually moves the position down. So as you write more stuff, so for example, if we write pack of, it keeps writing and then the position just keeps going downwards. Okay. One thing I forgot to mention was notice that kind of like in cout, you can chain these I call these alligator. Okay, these alligator operators. You can chain them, and it's just like you send the first thing in, then you send the second thing in. All right. Any questions? Yes, question.
So each time you do see out, you're essentially you're reprinting whatever you've redefined OSS to be, and you're just reconfiguring the characters OSS has.
Good question. Yeah. So let's see. Yeah. Okay. So the question was when we print to cout, we're essentially reprinting what is inside the string stream. Is that what you mean? Yeah. Okay. Yeah. So good question. So yeah, that's exactly what is happening. Where inside your stream, notice that every time we print, we are still printing the entire thing. The .str method, it takes everything in the buffer and it just turns it into a string and returns it. Question? Yes.
What happens if you don't have a .str? Does it not work?
You mean if you just print the? Good question. Let's try it. So I think what will happen, my guess is it's gonna print 1. No, that's gonna print 1. It's gonna print 1. My guess, yeah. Let's try it. Okay, yeah. Another thing it could do is it's gonna warn you like you're not really supposed to do that. So it's gonna warn you, but let's see. Does it run? No, it's an error.
Yeah, this is actually something that we'll learn later when we cover classes. So it turns out, so Avery mentioned that when you output it into a stream like cout, it automatically converts to the string. But the question is, how does C++ know how to do that? It turns out for weird classes like an OStream stream, we're actually the ones that have to define it. So keep that in the back of your mind, but that's something that we'll cover later in the class.
Mm-hmm. Yeah, and that's exactly right. Where right now this works for any primitive types, and it also works for some types that the creators of the STL created. But if you were to write your own class, C++ doesn't know how to print your own class, so you'll have to define it later. Okay. Question. Yes.
Since if you use double, you're converting to a string. Is it quicker to print a string or into the string?
Is it quicker to print to a string if it's a double versus like this over here?
Is it quicker to use a string over a double because you don't have to convert a string?
Good question. In this example, I don't want to go too much detail into this, but this thing is actually not a string, right? This is if you remember from Cynthia's lecture, this is a C string, and it's this weird like pointer thing that you'll learn later in the class, okay? These are technically not strings, so I won't say that any of these are faster than the other. If you were to actually use real strings, like if you said, okay, specifically, I want the string, I'm not sure if it's faster. It might be. It might be faster. I'm not super sure about that. Okay. Other questions? Yes.
Sorry if I missed this, but what's the benefit of using like OStream stream versus just using cout directly?
Good question. So cout, whenever you print cout, it prints directly into the console. Okay. As we'll see later on, we're gonna want to be able to internally process some string. For example, here, if we wanted to keep processing our string, we want to first prepare it before we print it out. Then you'd want to use a string streams to be able to essentially go through your string itself, process it, and then when you decide, okay, I want the entire string to be printed, then you print to cout. Okay. One benefit of string streams is they're not connected to anything. All right. Being connected to an external source sometimes is a liability. right? If you wanted to process a string, you can't just cout it, because otherwise it shows up on the console. Yes, question.
Is it like bad practice to have the compiler just automatically convert the double to a string? I feel like it's doing a lot under the hood, isn't it?
So you mean like as opposed to creating like a string like that?
Yeah.
Okay. So for example, sometimes that's inevitable. Like for example, if we actually had a variable double size equals 16.9, and then if we printed this instead, yeah, then this is oftentimes what's useful, where when you are printing something, you're actually printing a variable, not like the exact value itself. So sometimes you don't actually know what value is in the variable. So sometimes this is like necessary. Exactly, if it's wasteful, you'll have to actually look into the how the that operator is defined. Sometimes they usually do some sort of cool optimization to make sure that doesn't happen. But for stream libraries, you can ensure that these printing operations are relatively fine.
Okay.
Yeah, question, yes?
What we're doing essentially here is that we're appending the string, right?
Mhm.
The string of SS. And if we do like string 8, is it gonna like append at the end for both cout that we did, just both lines of code? Is it gonna add to the end, or is it gonna just add the first like OSS size string and gonna overwrite again?
Yeah, good question. So you're saying if when we did this, what would happen? What this does, the only thing it changes is it changes the position so it starts at the end. So any write that you do, you can always just make sure like you know where the write is happening. There's a small mistake here. This arrow goes to the end.
Then we write, if we write again, it's gonna overwrite this.
Sorry, my bad. There's a small mistake here. The arrow, when you write something in there, it moves the arrow down. So for example,